Example problem number 2. A billiard ball, 0.160 kilograms, rolls with a speed of 5.00 meters per second. It hits a cue ball, originally at rest, that has a mass of 0.170 kilograms, which rolls forward at 4.85 meters per second after the collision. How fast does the billiard ball roll after the collision? Start out, draw a picture. We have a billiard ball and a cue ball. The billiard ball is approaching the cue ball at 5 meters per second. A collision occurs, and then after the collision, we have the billiard ball is still there, and the cue ball is now moving to the right at 4.85 meters per second. Now, just as before with example problem number 1, momentum is conserved. So before the collision, we have P1 plus P2. After the collision, we have P1 prime plus P2 prime. We say prime to indicate that yes, it is still the momentum of the first ball, the billiard ball, but it is the momentum after the collision has occurred. This is indicated by the prime mark or the apostrophe, depending on how you want to refer to it as. P is still equal to mv, so P1 becomes m1v1, P2 becomes m2v2, P1 prime becomes m1v1 prime, and P2 prime becomes m2v2 prime. Notice that M1 and M2 do not receive prime markers, unlike V1 and V2. This is because while the velocity changes after the collision, the mass of each object does not change. Continue on to substitute. M1V1 becomes 0.16 times 5. M2V2 becomes 0.17 times 0. M1V1 prime becomes 0.16 times V1 prime. M2V2 prime becomes 0.17 times 4.85. Math now. 0.16 times 5 is 0.8. 0.17 times 0 is, 0. 0.16 times V is 0.16 times V. And 0.17 times 4.85 is 0.8245. To solve this, we need to get V1 prime by itself. Our first step is to move 0.8245 by subtracting it from the right side to the left side. Subtracting it from the right eliminates 0.8245. Subtracting it from the left actually gives us negative 0.0245 kilograms times meters per second. This is now equal to 0.16 times V1 prime. To solve for V1 prime, we divide by 0.16, as indicated right here, and we have negative 0.0245 kilograms times meters per second divided by 0.16 kilograms. This equals negative 0.153125. We had 3 sig figs originally at the beginning of our equation, or beginning of our problem, as shown here once again. 0.160, 5.00, 0.170, and 4.85. Rounding for significant figures therefore gives us negative 0.153 meters per second. The negative in this case simply indicates that the billiard ball is traveling in the opposite direction that it was originally traveling. That is all for problem 2.